Good afternoon, everyone. My name is Riley Chekarova, and I'm the Executive Director at the Toronto and Area Road Builders Association, or TARBA, and your moderator for today's seminar. Founded in 1957, TARBA is the collective bargaining agent with LIUNA 183, Operating Engineer 793, and Teamsters Local 230 on behalf of unionized contractors working in the Greater Toronto and Simcoe areas. Our members perform majority of transportation and maintenance for municipalities, the Ontario Ministry of Transportation, Metrolinx, and other provincial agencies, as well as residential and industrial owners. Thank you for joining us today on Global Recycling Day for an insightful discussion on recycled crushed aggregates and the case study of York Region's VivaNext project that used the material to reduce project costs and improve sustainability. We have more than 250 attendees from municipalities and consulting engineering companies from across the province, a true testament to the interest in this topic, building more sustainably and stretching capital dollars further to deliver the critical infrastructure our communities need. Diving right in, we wanted to start with some definitions. Asphalt and concrete are 100% recyclable and can be reused as valuable construction materials. Reclaimed asphalt pavement, or RAP, is processed hot mix asphalt material that is recovered by partial or full depth removal. Reclaimed concrete material, or RCM, is removed or processed old hydraulic cement concrete. The topic session, Recycled Crushed Aggregate, or RCA, is reclaimed asphalt pavement and or concrete, and the main topic today. RCA is a sustainable product that offers some of the greatest environmental benefits at a low cost. These materials have already met performance specifications when they were originally used, and when reclaimed, undergo an additional rigorous process of crushing, screening, testing, and quality control to be repurposed for their intended application as construction material in new projects. And Dominic, our expert speaker today, will have more for that as part of his presentation. Extensive testing in Ontario and internationally has shown that RCA is a high-performance material for an increasing number of applications, with numerous studies concluding that its geotechnical properties are equal and at times superior to primary aggregates. In fact, when RCA conforms to OPSS 1010, project owners can be confident that these materials will meet all performance requirements and quality expectations. The OPSS 1010 is administered jointly by the Ontario Ministry of Transportation and the Municipal Engineers Association, including representatives from the construction industry. It allows aggregate used in road bases, shoulders, and backfill to be composed of up to 100% recycled concrete and up to 30% recycled asphalt. Hot mix asphalt can also contain up to 30% RAP. Despite these provincial standards, municipal standards and setting their own local policies. As a result, practices can vary widely by municipality, really eroding some of the cost savings that we see with this product, even in economically significant regions like the Greater Toronto Area. For example, municipalities have specifications requiring primary aggregate only as part of their tenders, missing out on the benefits RCA use offers to both municipal capital budgets and their net zero targets. RCA also has broad-based industry support, and these 9 organizations that include Good Roads and the Ontario Society of Professional Engineers are strong advocates for increased RCA use. Now, a quick overview of the important economic and environmental benefits that you heard in part of the video. Every year, tens of millions of tons of asphalt and concrete are removed from construction sites across Ontario as roads are repaired, bridges are maintained, and other critical infrastructure is replaced or expanded. If they're not recycled and reused, these valuable materials will end up in landfills, further exacerbating our landfill capacity. The material significantly lowers carbon emissions, pollution, and project costs associated with long-haul trucking of that material, while performing equally or better than primary aggregates. The shorter distance traveled also means less traffic congestion and wear and tear on our roads. Lastly, RCA preserves non-renewable resources and extends the life of existing pits and quarries. Question repeated was around the cost and emission savings. So as some of you know, transportation is up to 60% of the cost of aggregates. This means that every extra kilometer aggregate has to be trucked to a job site, increases the overall building costs and carbon emissions. And RCA is available at a fraction of the distance to new construction sites. The chart to the right, provided from research by EXP, estimates the fuel consumption and associated greenhouse gas emissions for the 25 million tons of aggregate that's produced in the GTA. As expected, longer distances traveled require more fuel and emit significantly more GHG emissions. As part of the EXP research, they also examined RCA use in 4 different projects, from a parking lot to a big box store distribution center in the Greater Toronto Area. The research found that the higher amount of RCA used on a project, the bigger the cost savings and carbon reductions. On average, across the 4 projects, the savings were $8 per ton, and the carbon emission reductions between the primary and recycled aggregate were predominantly derived from the shorter distance travel. As you can see from the chart, that is 18 kilometers versus 80 for primary aggregate, 6 kilometers versus 115, 10 versus 50, and 14 versus 70. And you can see the project savings for each one on the right-hand side, along with the GHG emissions in metric ton. The biggest impact for these economic and environmental savings can be found at the municipal level. In Ontario, just over 50% of all aggregates are used in the construction of roadways, bridges, and tunnel infrastructure. Municipalities in Ontario own and manage more roads than the provincial and federal governments combined. In fact, municipalities are the largest consumers of aggregates, using about 60 to 70 million tons per year, with 50% of their budgets allocated for construction and infrastructure. So with that overview of RCA, we'll now dive into our case study and how the material was used by York Region, Dufferin Construction, and D. Krupe and Sons in the VivaNext transit project. First, we'll hear from Exxon Fard from Dufferin Construction. Exxon is an accomplished leader with 20 years experience in the heavy civil construction and infrastructure sectors. His expertise lies in business transformation, project optimization, and managing complex heavy civil and infrastructure projects across sectors such as railways, highways, commercials, airport, municipalities, maintenance, and private land developments. Exxon played a key role in the VivaNext Yonge Street project, progressing from design coordinator to project director. He holds a professional credentials as a professional engineer of Ontario, project management professional, and a Master of Engineering from McMaster University. Exxon, over to you.
Thank you, Rally. Thank you for your introduction. Glad to be here. Thank you to everybody, audience, Dominic and Jason. Pleasure to be on the panelist with you, gentlemen. We did a great job together. I just want to make a note of it, respect to our RCM success that we had on the project. There were a lot of other key individuals from the consultants and the stakeholders that were involved to make it really happen. Goes back that the relationship matters, and creating the environment that everybody having a sustainability mindset is a key. So a little bit high level what the project is about. So the owner, obviously Metrolinx and the York Regions, and the owner agency, York Region Rapid Transit Corporation, they were the agency that managed the entire Viva program within the York Region. And obvious that Dufferin Construction was joint venture with Aecon for Rapid Link Constructor. We were the design builder for the project. What the project was about, building the bus rapid transit in the middle of the Yonge Street. As you can appreciate, it is a major utility relocation required. The project was around 10 kilometer, almost 10 kilometer within the 3 major segments, one in a town of the Newmarket, the other 2 in the town, city of Richmond Hill. Building the median rapid way, full road reconstruction and widening required, as long as the bike lane as well. 20 bus stations within the corridor. Beautiful landscape on either side of the Yonge Street. Almost 6 kilometers of the landscape involved on that project, and also within the median. Part of the program required underground work in the wet utilities in terms of the storms and the sanitary and the water main, and also rehabilitation of the existing. Retaining wall required along the corridor because of the grade differences that created it, and also the culvert improvement and then head walls. So you can imagine how many granular required on the jobs, as you can see. Before we dive in a little bit on the case study, I think it's an opportunity I share with you what we see as a sustainability happen within the projects and what is really common in our industry and particularly in our Dufferin operation is really understanding the networking of the source to the projects. As Raleigh mentioned, the carbon footprint is really important to consider, and the recycle of the material, the terms of the concrete and asphalt, and a few of the efficiency. One thing is that there are other products that Dufferin concrete. We're really proud of the EnviroGuard that they use on the Viva Yonge Street to have that sustainability enhancement to recycle aggregate and also recycle water. And the mix optimization is top of my mind when it comes to the wrap asphalt, recycle asphalt in the mix optimization. So what was our project team approach? Really, when it comes to the sustainability, we got to understand that what really moved the needle on this job where around 200,000 ton aggregate required for the road base and sub base and the trench backfill. So it was an opportunity and really moving a needle. So everybody understand why we're considering the recycle aggregate, particularly on the RCM, recycled concrete. And in order to get it to the finish line, we really need to understand the owner's concern and the constraints they have and the requirement guidelines and working toward the solution. And everybody was part of the solution. Working collaboratively, we developed the controls and measures in place. Obviously, OPSS 1010 is a great guideline, but there's other concern that came up through the development of the procedure in terms of the permeability, and Jason is going to talk about that. That we had some guideline to be monitored every 10,000 ton. We did that sampling to understand where the permeability is. And also the lead designer's involvement and the engineering review, the entire process help us to get over some of the roadblocks. And when it comes to the quality control, it's got to be at all the level. At the source, obviously, that Dominic is going to talk about, but at the job site, we had that to make sure the physical and the gradation and permeability met, and the QA, obviously, through the entire process was established. One thing I want to point out, you can clearly see that on carbon footprint consideration here. You see the red dot on the right-hand side that shows the crew PR that help us to recycle, and the left-hand side at the bottom was the original quarry. You can see, and then the project was in the blue line, so you can see how much saving could have been done on the hauling and also the emission and in terms of the carbon footprint. It was a great initiative. And also, you can imagine how much concrete we remove on the job. Over 500, just 500 loads was a sidewalk going back to the Kubi, recycle and come back to the job. So it was a great opportunity for the sustainability opportunity there. So to wrap up my presentations, I think really understand what's your project requirement. There's great guidelines you can use to develop that sustainability solution. And it comes, you need, our TARBA members, we have a great contractors that they've done quite a bit work in terms of the recycling material, and tell us what your needs are. Let us know what are your requirement and what's your benchmark, and have a flexibility and a mindset that you give a try and you have not done it before, and develop that quality control process and quality assurance process that give you that confidence that's going to work. So Raleigh, this is the end of my presentation. Pass it on to you.
Thanks so much, Jason. It's always great to start off with the contractor perspective for the project. Now we'll move on to Jason Mainprice from York Region. Jason has been in the municipal transportation engineering sector for more than 20 years, including 10 years as part of the York Region BRT delivery team. He was responsible for items including design, construction, commissioning, handover, and warranty of multiple VivaNext segments, most specifically the Yonge Street section in both the city of Richmond Hill and the town of Newmarket, where recycled granular material was used. Jason graduated from Humber College with an honors in civil engineering technology. He has a CTEC designation from the Ontario Association of Certified Engineering Technicians and Technologists and is the past president of the IMSA Ontario chapter. Jason, you have the floor.
Thanks, Riley. Nice seeing you again, Asan and Dominic. Thank you for being invited to discuss this. It was a great project, very successful. Obviously went through some trials and tribulations and lots of great discussions. But yeah, I'm glad to be here and talk about this specific part of the project that appears to has gone over really well. So as Asan mentioned, York Region does follow OPS 1010 Muni, but we have amended. So in our roadwork specifications, we specify OPS 1010 with amendments that go through our procurement process. Part of that amendment is in the general portion. And what we do is we outline that contractors have to request the use of that, meeting a minimum criteria. So that's something that the design builder, in this case Dufferin, knew. So they put in the request, and then we went through their criteria. Krupe, knowing and working with York Region in the past, knew our requirements, so they got on that process. Part of that design included the testing. So we need to know the sources of the material, where the production plant is, the stockpile location, and we have good relationships with many vendors, but in this case, Krupe, they know our requirements. Sometimes they even have a sign for our stockpile, York Region. The date of production and the quantity. So we do it on an acceptance based on a stockpile rate or each stockpile. And then showing that it meets the criteria outlined in the 1010 requirements. We produce written confirmation, or they produce written confirmation of that stockpile, including the LS testings as outlined in the OPSS. And then under granular A, we also amend it, and we are very specific to the 1% of deleterious material, both in coarse and define. We outline both in the total mass. And the specific deleterious material that we look for testing, and Asan and Dominic, you'll know this obviously because you did it, is gypsum. That's the one area that we are very concerned about. And as time goes on, if you start using this material, you will see the difference if it comes to your site between something that is contaminated with greater amounts of gypsum or deleterious than if it meets the criteria. So on this project with the design builder, they used OPS 1010 plus our amendments, and that became a project SP, special provision. So knowing that we were going to use this product, York Region also, we prioritized our permeability in our drainage base. So our roadway longevity to prevent going back and reworking in an early life, which would discredit all the savings that you see in both economic and the emissions, is making sure that this is this life of this roadway lasts what the design criteria was. So part of that is the QC process, which Dominic will speak to, starting at Krupe's. and then the designer and the builder get together and they do their QC and quality assurance based on so far and so forth, plus our oversight as well. So York Region Rapid Transit Corporation administered the project on behalf of York Region, and they had a third party, what we called the Technical Advisory Construction Oversight Team. They also had a quality assurance as well. So the quality control and quality assurance was priority and was obviously accomplished through this process. So to help this, we also spec rigid subdrains, and another great conversation me and Asan had over the life of the project was, why do you guys use rigid over flexible? And the reason for that is just basically experience. We've seen that we get better performance and longevity out of rigid subdrain over flexible. We still use flexible in the radiuses, of course, but in the straight line tangents, we use rigid. And that has obviously paid dividends over the life as the performance over. So we just are coming now out of the 5th winter, 6th, because the base had base course asphalt on it for the one winter. So it's actually the recycled aggregate has gone through 6 winters. Coming out of the 5th now. This was as of yesterday. So the performance of the roadway as far as bottom-up issues, none. We have no potholes, not a single pothole in along the segments. No heaving. You have your performance issues around your nodes. I mean, you can't get away from structures, specifically the ones you have in wheel path. And this wasn't a total reconstruction, obviously, because we wanted to reuse some of the infrastructure to lower our impact. So some of the old catch basins are now maintenance hole structures in the wheel path. So those do take a beating, and we've seen those. But as far as the actual roadway that is supported by the RCA, we have seen no issues. So York Region in general encourages and supports and even specifies many ways to use both RCM and RAP. In our roadway design guidelines for pavement design, we obviously spec OPS 1010 and 1151 and certain criteria that it meets, but we also want to see from the geotech engineer a design to reuse, recycle, and the least option is removed. So just like reduce, reuse, recycle, it goes in that priority, right? We want to reduce first, reuse second, recycle last. The same thing goes for our design criteria. So can we reuse it? Can we recycle it? Or do we have to remove it? And even if we do remove it, can we bring it back like we did with the RCM? So something like a styrene project, which is, in place recycling. So we don't even remove it from site. We're recycling it right in place. And that's something that another VivaNext project used. And I don't want to discredit what we did here, but just showing how much we encourage this sort of product. We used it on another VivaNext project. We also utilize RAP in our base course super pave. And of course, we use RCM in our granular base. So.
Perfect, Jason. Thank you so much for that insightful look into the region's sustainability priorities and management of the project. All questions, and yes, the presentation will be shared, and this whole session will be recorded and made available to everyone as well. So last in terms of the presentations, but certainly not least, I'd like to welcome Dominic Pasalacqua from D. Kruppe & Sons. Dominic has 37 years experience in the asphalt paving industry. He is an expert in asphalt plant operations and is an industrial millwright mechanic and a certified engineering technician. He started his career in 1983 as a plant foreman, and throughout his career, he has installed and taken down plants across the province and Eastern Canada. Dominic is a regular presenter at various association events and training schools related to asphalt plants operations, and we're thrilled to have him here today. So Dominic, without further ado, we'll give you the floor.
Thank you very much, Riley. And I'm telling you, it's exciting to be here today to talk about a project that I think went extremely well. But you know, not all projects start off like that. They start off with hiccups and then they get smoother. And now we can actually celebrate and talk about what actually happened. I'm going to speak to you in regards to the supplier perspective of the Rapid Link project. So Krupi was chosen for the services provided, asphalt mix, the accepting of the concrete rubble from the site, and producing recycled crushed aggregates. We had to be able to show that we had confidence to transform the concrete rubble into a recycled crushed aggregate. Krupi had to propose that we were strategic to the job because we had a location that was geographically well positioned for the project, and Krupi had to show Rapid Link that we had a strong track record for quality, which Jason alluded to earlier, and we had to show what to expect from Krupi, safety being a huge priority, quality and service. Now, you've seen the slide before. I'm going to just briefly tie in. So Y32 was the northern end in Newmarket, Y22 and Y21 were the southern end in Richmond Hill. But our main focus was to supply and place the asphalt, but the main point is the 3/4 recycled crushed aggregates for construction of the dedicated medium roadways, the boulevards, and the new bicycle lanes. Now, this is a very interesting slide. York Rapid Link's contractors removed the concrete curbs, sidewalks, pads, etc., and delivered the material to the Krupi site. Krupi processed the material and produced recycled crushed aggregates. Krupi was responsible for the quality control of the recycled crushed aggregates, and Krupi loaded the material onto the York Rapid Link contractors' trucks. Now, one thing I want to point out here is the first image on the top right, July 2015. That's what Yonge Street and Major Mackenzie facing southbound. You can see that there's 2 lanes facing northbound, a left turn lane, a center island there. Then you can see 2 southbound lanes and a merge lane on the right. As you go July 2019, you can see the construction starting to happen. They got rid of the center median. You can see the 2 lanes coming northbound, the left turn lane, 2 southbound lanes, and you can see the work happening on the far right. What I'm getting to here is, and then you see June 2023, you can see that the expansion of the roadway, that it's visible, mind you, and Jason talked about earlier, there's no signs of differential settlement at this location and throughout the whole project. This shows how well recycled crushed aggregates held up. Now, the customer first approach that Hassan also alluded to, we think Rapid Link chose Krupi for the asphalt on the project and integrated acceptance of all the concrete rubble and to provide recycled crushed aggregates in return. Now, Krupi had to ensure that we can accept all the concrete rubble from the site, which we did, and that's why we selected that site there, which is closer to the job site. And we had to also show confidence that we would supply a quality product and ensure that we did not cause any delays to the job. So we had to make sure that the product that we sent out there, we couldn't afford to send out a product that would have to be ripped out and put down again. That would cause delays to the job. So we did go through rigorous QC testing, which we'll talk about. Krupi also had to guarantee that we would be able to accept the rubble from the site and load up the trucks to gain efficiency by utilizing backhauls. So some of the trucks that came down, after we had the stockpiles in place, we would actually load up the material and send it right back to the site. Now, transforming concrete rubble into recycled crushed aggregates. That is one of our specialties at Krupi's, and we selected a site that could accept the material. You can see the site in the image in the middle there, and we have a crusher on site, and to produce a quality recycled crushed aggregate, we had to do a lot of QA and QC testing. So what does this entail? So first thing that we had to do is inform Rapid Link of our safety protocols. So then when a truck shows up to our site, there would be no delays. One thing to add is that we always followed the safety protocols that were in line with RapidLink safety protocols. So if anything happened on a RapidLink site, we would actually immediately do something with a Croupier site to make sure that we're always in line. Now, we have to inform RapidLink of our QC protocols, in particular, inspecting the incoming material and providing documentation. We would print a ticket for every load that came to our site. After the truck entered our site, we would take another look at the material as the material was dumped in the yard and separate the material based on a specific criteria, whether it's concrete and asphalt, etc. Now, we started crushing the material, and now we had a stockpile. And we would start crushing material into 3/4 crushed aggregates. We chose to do a gradation every 1,000 tons. We did a physical properties every 5,000 tons, and we also did proctors every 3 months. We felt that this protocol would guarantee the RapidLink the best quality product. Also, if we had any non-conforming material, we would move it to a separate pile and then reblend it in to make sure that it became a conforming material. And if there's any non-conforming materials that cannot be produced into aggregates, such as plastic, wood, rebar, etc., it was disposed of immediately. Once the final product passed specification, then and only then would it be loaded out onto RapidLink trucks. Now, this is, we talk about sustainability, like what actually happened. Just to give you some information here, an estimated 5,500 loads of concrete rubble were dumped in the Croupier yard. This all happened on a 4-acre dedicated area. Now, that concrete that got dumped in the yard, that's not enough to produce all the material that was shipped back to RapidLink, because there was over 250,000 tons of 3/4 recycled crushed aggregates. The first load was shipped in April 2017, and the last load was shipped in June 2021. Over 2,000 tons of 3/4 select crush was shipped out, and the loads range from 20 tons to 2,500 tons in a day. Okay, the quantity of recycled aggregates shipped out range from, 20 tons to 2,500 tons. This equates to 1 truckload up to 125 truckloads shipped out daily of recycled crushed aggregates for RapidLink. We did this on top of all the regular business that was happening out of that site. Loading and weigh out of the final block was also important. After material was dumped in our yards, the vehicle would usually backhaul material back to RapidLink. This was an efficiency thing that helped out RapidLink and the project. One of my last slides here, just to continue on certain points. Recycled crushed aggregates is a key component of a circular economy because it can and was used as an aggregate in the construction for RapidLink. This reduced the need for the new raw material and kept the waste out of landfills. This material was used on construction of a dedicated median, rapid way medians and boulevards, new bicycle lanes, and could also be used in road beds, parking lots, and could be used in construction. This reduces the demand for virgin materials by offering a cost-effective alternative to quarrying new resources. And the challenges that people usually talk about recycling concrete because of quality, consistency, and performance issues were eliminated because of the QC plan and the frequency of testing. This is one thing that everybody should think about is if you're doing this, you have to make sure you dedicate a good QC plan to make sure you have quality going back out to the field. And the availability of costs are always an issue, but this material, recycled crushed aggregate, can be reused over and over again. So that savings will always be there. And thank you. And that's back to you, Riley.
Thanks. Sorry. Thank you so much, Dominic, for that detailed look of both the material production and the quality control management. Those are the questions. So sorry, that have come out the most about that. So I think that was really well detailed, and we'll get into some of those further questions as well. Thank you all for keeping your presentation so timely. It means we have lots of time to address the number of questions that have still come through. And a lot of them, as expected, are about cost savings. So as part of my introduction, I shared that cost saving modeling that EXP had created for those 4 projects. And I'd love to just ask you that question. Do you see these cost savings in the market as part of this project and other ones that use recycled crushed aggregate? And maybe, Exxon, if you want to kick that off.
Yeah, no, absolutely. You know, as I mentioned, is that when it comes to the sustainability and recycle, that the needle mover really matters. We see the savings. Obviously, the sources really matter where it is located with respect to the projects. But on this specific project, yes, it was a saving that did blend in through the whole design build program that we had. But the saving varies depending on the projects, but we see the industry varies from 10% to 30%. It's really depending on where the source is, and having that synergy as the material being removed, going to the location to be recycled, coming back, right? So we've seen that in the industry.
And Jason, what about from the region's perspective? Do you notice that difference as part of the tenders and the overall project?
This specific project, we didn't really see the pricing just because it was a design build. I did a quick check on our DC rates because we do use recycled often. I checked with our capital delivery team before this, and we've been using it for quite some time based on the criteria, like I mentioned in our amendments. And our DC rate from 2021 to 2024 moved around $10 a cubic meter. But I would say that the price is super competitive for roadway granular, and it obviously shows that in compared to the virgin pricing that I've seen recently, recycled is a cost saving measure, but also the environmental measure as well, right? So.
Absolutely, thank you. And there was a question that came through about the permeability. So, Exxon, maybe I'll throw that one to you. Was the permeability of the granular A tested as part of the project?
Yes, it did test it, and you know, that's a really valid question. So we're at the beginning of the projects, our quality assurance, we're a design builder, so we're doing the quality control, and we do the lead designer review, and we do the quality assurance, working with the owner engineers. Part of that was establishing what frequent we're going to do that permeability test. So the permeability, we before proceeding with the recycle, when we had the stockpile, we did the permeability prior to that, and also on the job site when it came, we did the permeability with the 3 different sub-consultant, did the test to make sure that criteria meets the granular A permeability. And on this specific projects, we use the granular A, most of the granular in subdivision granular B. The reason is that you know, where the trench backfill with the road base and everything else, actually finding the synergies that just using the granular A and getting approved for that pavement design.
That's great. And I have maybe a somewhat similar question here on the maintenance side. Is there any special asphalt maintenance procedures that are anticipated for this type of project? I'm not sure if anybody wants to take that one.
I'll take it. There is a life cycle, or like an O&M for these projects, which is you do a preservation, you know, in that 3 to 5 year mark to expand, and you do a top lift, shave, and repave around that 15-year mark, and rinse and repeat to try to get, you know, above 30. The idea is to get 50 years with this proper preservation, crack sealing, all those mitigation measures to avoid causing a top down early life degradation. So the idea is to get, you know, minimum 30, but you know, it was designed for a 50-year life.
That's great. I think, Dominic, there's a question here for you in terms of the accepted material. Was crushed concrete from washout or clean out from concrete delivery trucks accepted?
On this park, so if you look carefully, even at the image that's on the screen right now, we do keep it aside and we separate it. During the presentation, I can't remember if it was 2,000 or I think it was 2,000 tons that was shipped out of the RCA without wrap, which we call select crush. So we do keep it separate. We don't put it with the rest of the product.
And that's part of that quality control
Correct.
you described. That's great. There's another question here a little bit more broadly. Can you talk about, from each one of your perspectives, other types of projects that you've worked on that have used RCA?
You want to start with me?
Sure.
Okay. Well, actually, this is another exciting story. We've had, and the reason why I want to mention it is because it just happened recently, and it's because of something that York Region has done. Because of York Region's lead, they had a project on Major Mackenzie where they were using recycled crushed aggregates right on Major Mackenzie, and we were a subcontractor to a job that was just south of Major Mackenzie in a subdivision, and it was the city of Vaughan, and the city of Vaughan had an operations center. And because of York Region allowing RCA and the new Kirby sidewalk that they're putting in, we proposed it. We weren't even the general. We helped propose it to the city of Vaughan, and we converted that whole subdivision for the first time in Vaughan to use recycled crushed aggregates and Major Mackenzie and Keel, and also on their own operations center, or else that would have been crusher on limestone. Well, that's a great news story.
That is a great story. Thank you so much for sharing. Exxon, you want to share yours?
Yeah, no, we've been using, the Ministry of the Transportation is great, and you know, they've been using on the highways recycled material, and also at the airport, Pearson Airport, we've been using recycled material, and they really supported on that.
Fantastic. Jason?
Yeah, I'll just reiterate that York Region has been specifying our RCA either in the granular or in our asphalt superpave for quite some time. So, I mean, basically too many projects to name. This was the first one, though, that I was really involved in the complete see-through from the design end all the way through to see what it takes to be successful. So, you know, I think that's as far as I'm concerned, special, but you know, speaking to my capital delivery team, it's kind of routine for them. So
That's great. That's great to hear. And I will just echo that York Region has been a great leader in this type of sustainability, and we really appreciate that. And it's great to have you share your perspective with many of the other representatives from municipalities across the province here. There's a question that came through about any limitations to the application of where RCA can be used. Anywhere where you would recommend that it's not appropriate.
well, my take on it is if Grant A can be spec'd, then it can be used as any Grant A, as long as it meets the criteria as outlined in 1010. But you want to always prioritize permeability and drainage. So you can't, any material is not going to do well if it can't drain. That's,
yeah,
you got to help it.
Yeah, I see a lot of nods. Anything else to add before we move on? Okay. There's been lots of questions that sort of want to know more about the quality assurance and quality control and what measures were implemented. Maybe you can talk a little bit about the joint process. It sounds like it was very collaborative across the board on how some of those parameters in that plan was put in place.
Son, if you want to lead it.
Yeah, so the guideline was there with the old PSS 1010. So at the beginning, we really need to sit down with the stakeholders, understanding the concerns. So as I mentioned, the job was through the town of the New Market, through the city of Richmond Hill, understanding the constraint and understanding their need. Obviously, we had a design team on board, our lead designers, and also we had a geotechnical engineers on board as well. And they developed, within support of the York Region, a really robust process when it comes to the quality control and respect to the quality assurance. And develop the additional testing that need to be done to give that confidence to some of our stakeholders and the owner, actually, because it's a significant amount. So it's been what we learned there. There's always had their own experience, but when you put everybody together, their experience, and share the knowledge, there's a solution. And OPS said 1010 is a guideline, but it's proof that we can start from the 1010 and understanding the constraint of each. As Jason said, the permeability was huge for the York region. Understanding the quality control, understanding how we leave the job at the end of the shift. We had to make sure we had a positive drainage and not having the water get trapped. Having a good quality control on the subdrain. Me and Jason, we go back and forth on the subdrain type, right? And really, the lead designers and the consultant, they really support us through that.
That's great. Jason, anything to add?
Yeah, I think Asan mentions it's great. There was a lot of experience at the table in the discussion of allowing this material to come forward, because a lot of our amendments come from past lessons learned, right? Like we've used 1010, we've had some issues. Where did those issues arise from? We didn't just say, okay, we're never using this again. What did we do wrong? What can we do to make it better and improve? And that's why we've come up with our amendments. These amendments are available on our website through our road design guideline portal. And you just have to log on. The password, the login name and the password is right there. And you get our full road design guidelines, and there's some specifications in there. But they are public documents. They're there for consultants and other municipalities to use, similar to the Empty Hill Resource Library.
That's great. I have a couple of more technical questions here. I'm gonna try asking them. If you're not sure of the answer, we can always circle back, and I know exactly who's asked it, so we can always provide them an answer later on. The first one is, did you increase the granular subbase and base thickness in comparison to using primary aggregates?
To answer that question, no, actually, when we changed it to granular A, we had an opportunity to actually reduce the pavement structure. But as Jason said, the entire Yonge Street was not designed to be full reconstructed. So having the consistent subgrade drainage, we had to maintain the existing as a minimum. But there's opportunity if the pavement structure change, and you need to work with the designers. But on this specific project, we didn't change it, because the existing granular that we tie in, we need to have a positive drainage at the level of the subgrade.
Our asphalt thickness did a change in those scenarios.
The asphalt thickness changed,
Yeah.
yes.
Yeah, to make up for that less granular. And we also use some a richer mix of asphalt. Maybe Dominic, if you want to just kind of allude quickly on that.
Sure. So yeah, going back to what they just said, so I do believe in drainage, permeability, and all that. That's I think a key item that we should make sure we stick to all the time. But on the asphalt side, so what we did first is Super Pave 25. It was a rich bottom mix first, so it had more asphalt cement in it. Then we did another Super Pave 25 layer. Then we did the 19 mil. No, I think some areas we did 19 millimeters. Some layers we did right up with Super Pave 25, and then we put the surface course on top. That's the design structure.
Yeah.
And Jason, just to add on, Raleigh, maybe Jason, in comparison, like how the whole project turned out. I know we talked about there's no differential settlement, but especially you showed that image earlier of the roadway after 5 years. That is actually a great achievement on any project.
Agreed. Yep.
So we have a very diverse way of asking a number of different questions. So I'm going to summarize all of that into a broad question to say, did you have to change any of the design elements or the construction or anything like that because you use the recycled crushed aggregates versus primary aggregates?
Yeah, the
Shakes?
method didn't, sorry, the method didn't change. The quality control and the quality assurance, we changed that to make sure that the material meet the requirement, but the method stays the same. We found the synergy actually using the recycle, as I mentioned, removing the concrete, going back, aggregate coming in, right, on the job site. So, but the method of the construction didn't change.
Great, that's perfect. Now, as the moderator, I have the privilege to ask the last question, and I'll allow each one of you to provide an answer, and that is, what is your advice for other municipalities that are looking to use a more sustainable product like RCA? Dominic, I'll start with you, then Jason and Essen will give you the final word.
Okay, my personal opinion, you have a high quality aggregate when you first produced concrete or asphalt. And that's the material that's coming back to our yard. So if you think about it, it's concrete, which is high quality aggregate to be produced in the first place. That's the material you're crushing to put back in as a granular A product. So for me is, why wouldn't you? You're getting a high quality aggregate.
Great point. Jason?
I think that, we've been building roads for a long time. The requirements have been there for quite a while. Roads have been successful and roads have failed. Just because you build a road with RCA doesn't mean it was the RCA, and it fails doesn't mean it was the RCA. So, you got to do a deep dive. Don't focus on the mistake, focus on the corrective action, and build from it, like York Region did with its amendments. Just based on lessons learned and using it. And we could have shied away and never used it again, or what we did instead was put all our heads together and collectively come up with something that works for us and has been working for us now for quite some time.
That's a great point. Exon?
Yeah, no, I think well said, Dominic and Jason. The one thing I would add is that sharing the experience and reaching out to the association and getting the feedback from everybody helps, right? We do understand that everybody has their own experience, but when you put everybody's experience, there's a learning curve that everybody seen it, and you can be open and share your constraint, and the contractors, believe it or not, we could be a part of the solution. And we have, working with the engineers, we can find that solution that works and give you that level of the confidence.
That is a great point to end it on. And I just want to thank all of you. We've chatted with a lot of different municipalities about this product. And the question that comes over and over again is, who else is doing this and how are they doing it? So I think profiling this project 5 years later, being able to show the performance of it was really insightful, and hopefully some food for thought for a lot of the audience on the call. In our last minutes, we do want to share just a few closing thoughts and some actionable items to help municipalities and any other project owners unlock that economic and environmental benefits of RCA. And what I'll start with is saying that for municipalities in particular, RCA is the solution to two big current problems: reducing construction waste and extending the life of existing pits and quarries. Ontario has less than 10 years until all of our landfills in the province are full, according to this live countdown run by Waste to Resource Ontario. And again, as municipal folks will know all too well, residential opposition can be quite powerful when proposals to expand or, God forbid, start new landfills, pits, and quarries are raised. And the other point is that, aggregates are the foundational materials for all the critical infrastructure our growing communities need, but they're also finite and non-renewable resource. The Greater Toronto Area already has an aggregate deficit. We produce about 25 million tons, but we already consume 73 million tons in all the infrastructure that we need to build for our growing population. And that number is projected to increase to more than 1.5 billion tons by 2041, all while we're exhausting close to market sources. And as I hope we made very, very clear, the further we need to travel for those aggregates, the higher the cost of construction and our impact on the environment. So I know municipalities are already struggling with the capital projects that they need to put in place. So this would really reduce their capacity to build even more with the cost increasing. So what you saw from the video, and this is sort of the big line numbers, is that if municipalities adopt just a 20% recycling rate, that would avoid extracting up to 33 million tons of new aggregates per year. It would result in cost savings of more than 264 million, and that's not accounting for some of the indirect costs like the wear and tear on existing roads from the long haul trucking. And GHG emissions, and this is pretty powerful, that would be equivalent to taking 15 million gas cars off the road for a year. And just in case you're wondering, that's way more than all the cars in Ontario that we have right now. And I will say the 20% recycling rate was selected because it is what the Ministry of Transportation, which I think Dominic mentioned, or Exxon, sorry, mentioned, has used RCA in the maintenance and expansion of our 400 series highways since the 1970s. So that's the rate that they're on, and I think it's actually just a little bit higher than that. So we do feel that 20% is a very achievable target for municipalities that would deliver on those significant costs and environmental benefits. And as you, I think, heard from all the speakers, quality control is what's paramount, just with any other material use, not exclusion. So mentioned at the beginning and throughout our presentation, there's lots of research and lots of case studies that have shown that when RCA conforms to OPSS 1010, municipalities and really any project owner can be confident that these materials will meet all performance requirements and the quality expectations. So this is why we would urge you, when you're considering the use of this product, effort should be directed to enforcing quality rather than restricting its use. And really in collaboration with industry is the most successful path that we've seen forward. So at the website down there, rcaontario.ca, you'll find TARBA's quality control plan that reflected a lot of the measures that Dominic included in his presentations. And it really provides a technically sound manual for producing, utilizing, and ensuring the quality of recycled crushed aggregates. And this can be used as a resource for producers, contractors, and project owners. And lastly, to leave you, with sort of what municipalities can do to capitalize on this, first and foremost is really to include sustainability as part of the initial project design. Make sure that RCA is included as part of the tenders for roads, bridges, sewer and water mains, subdivisions, transit projects, and it's not restricted to just primary aggregates. Aligning with OPSS 1010 would reduce administrative burden, ensure quality and compliance, and encourage wider adoption, and really collaborating with industry. On that same website, rcaontario.ca, you'll find some additional resources, including the EXP research that I mentioned, along with an additional document from EngTech on gradation equivalency, and recorded presentations from last year's seminar by both EXP, MTO, and Dominic, who's a great repeat guest here. So this concludes our seminar. Thank you to our speakers for sharing their experience and expertise, and to everyone watching for taking time out of your busy schedules to learn more about the use of this sustainable material. We really hope that you would consider the information provided today and become champions within your own organizations for the increased use of RCA in linear infrastructure projects. Thank you so much and have a wonderful Tuesday.